Hi, I'm Uttara, and I'm here to introduce the keynote speaker that we have for today, Dr. Carol Woodward. Dr. Woodward has been at the lab almost 3 decades now, and she is in the Applied Scientific Computing division at Livermore Lab. Before this, she did her PhD in computational and applied math at Louisiana State University, and she did her PhD in Rice University, and then Louisiana State University is where she did her undergrad in math. And her research interests are in numerical methods for nonlinear partial differential equations, and she leads the development and deployment of the SUNDIALS package, which is an award-winning package that gets downloaded about 100,000 times every year. And it is used worldwide in an array of scientific simulations. Dr. Woodward is also on the panel of several committees and organizations. So she's the vice chair for Standing Committee for Gender Equality in Science. She serves as the International Council on Industrial and Applied Math, and she is also currently the president-elect of the Society of Industrial and Applied Math. And today she's going to talk to us about how she almost became a microbiologist, but then ended up going towards applied math. And I'm very excited to hear more about that. And she will also talk about the numerical package SUNDIALS and explain how its capabilities are useful for simulations. And she will give us examples on how it is applied in those applications. So I'll give it over to Dr. Woodward.
All right, so first I want to thank all of the speakers, all of the organizers. As you'll hear me talk a little bit, they didn't have events like this when I was going through and was an early career. And to see this room full of strong, capable women in data science, this is exciting. I don't know if I can convey that, but how much it is, but it's really exciting to see it. So I want to thank the organizers for the time and effort to make this happen. These sorts of things don't just happen. I've been involved in organizing several of these and things like this, and it's a lot of time and effort and a lot of logistics where you're worrying about donuts and things like that. And yeah, thank you. Okay, so I was asked to speak about a couple of things. One was about my career path, including challenges and an overview of my current work. And then I chose to make some final comments. I put the weight of the talk on the first part here because, in all full disclosure, I'm not a data science person. When I do high performance computing, I do numerical software. And so I've been in the field a long time, with very related fields. So I chose to spend a little bit more time on my career path here and then say a little bit about what I'm currently doing with SUNDIALS. Okay, so any talk I give on my career path, I have to start with high school. High school was kind of that time when I started to kind of find what I wanted to do and what I wanted. And I also started to hit limitations and roadblocks. So I started high school. I went to one school for 2 years and another school for the last 2 years of high school. And it was a game changer, that change. The first one was in Lafayette, Louisiana, where I grew up. And I tried to take lots of math and science courses. I would have taken computer science, but that wasn't an option. And now I'm going to age myself. This was back in the 80s, right? So TRS-80s were a thing. BASIC was the programming language, right? There was no computer science offered at the school, but you could take typing. So I remember trying to set up my schedule for my junior year of high school and going to the science department head who had to approve somebody to take 2 science classes. And he looked at me and he said, "Do you really want to do this?" And I said, "Well, yes." And he says, "Well, you're going to turn into fruitcake if you take all of these classes." And I assure you, he did not say the same thing to my male classmates who had the same request. Right? And that's when I first started hitting some of those roadblocks that we get. And I honestly don't think he meant to do what he did, but he did it, right? And it's just those little tiny bits of discouragement that we all hit throughout our careers. As it turns out, junior year, there was a new high school being developed in Louisiana that had gotten off the ground called the Louisiana School for Math, Science, and the Arts. And they were recruiting for their third class. And so I applied and got in. It was a boarding school. It required me to leave my house at 16 to go learn math and science. But it was a new school and it was an exciting environment. And we had a faculty that was excited to be there and they were excited to teach. And so I put some pictures of some of the folks along the way in my career. One was Martha Talbert. She taught calculus and trigonometry by writing with one hand and erasing with the other, and you just had to keep up in the middle. But she believed that no person could not do math, and no person couldn't love math. And she worked really, really hard to make that happen for everybody, including the arts majors who were amazing sopranos or cellists or whatnot. They still learned to like math from Martha Talbert. So it was an exciting faculty, an amazing faculty, excited to be there. We had an amazing cohort of students there. There was lots of math, lots of science, lots of computer science. So then I really took off with computer science in high school. Even took a class in Lisp. So this also kind of ages myself, I guess. When later I was working with Emacs, I could actually do some Lisp programming, which was kind of exciting. Then I discovered that I really liked it. I liked biology, took a ton of biology, took a ton of physics, and took lots of math, right? I just loaded up, take everything maxed out and loved it. And what I learned from this high school was that the power of intense study with a strong cohort and engaged mentors, you can just excel, right? If you've got the right environment, it can really do wonders. And then I went to undergrad. So I did undergraduate at Louisiana State University. I started as a math major. I was very excited about math, but I had taken all these, microbiology and genetics and all these, AP bio in high school, wanted to continue on, started doing bio. I confess I hit organic chemistry. So you see a list of classes I take bio, I take physics, but chemistry is not on there. I've never found a love for chemistry, but I enjoy microbiology, but I decided this was not for me. There was just not enough math there. And I felt like it was more memorization to get into, organic chemistry and all of these things. It's just more memorization, less deriving. I like to derive. I like to understand where things come from. So I went back to math, but then I started I was hanging out with all these physics majors. And I started taking physics classes. I really liked physics. So I took a ton of physics classes, considered majoring in physics. I don't know if I actually switched. So I put a question mark if I was formally a physics major at any time. But eventually went back to math and ended up majoring in mathematics. So I was able to take tons of math and science classes, but I took no computer science. And this, I have to say, is one of my bigger regrets. I had no computer science, and yes, I'm talking to women in data science. So what happened is I AP'd out of a lot of the introductory computer science, went to go take the next thing in the sequence at LSU, and I had a faculty member that was speaking to the men in the front row of the class. They all assumed everybody knew where everything was and how to do everything in their environment. I didn't know where the computer labs were. I didn't know where the printers were. I didn't know where all of these things were. And it was not easy socially to just talk to the guys in the class. They just were not accessible. Yes, I could have tried harder, but I didn't. And so I dropped out and didn't take any more computer science. So I regret that, but it is, I think, one of those things. I'm not going to blame anybody but my own self because I could have worked harder at it, but it was not made easy either. Okay. I had professors that challenged my resolve to stay in math and science. I had a history professor who looked at me one day and he said, well, math, what are you majoring in math for? That's math is something you study for an intellectual curiosity. You don't major in that. There's no career in that. Okay. As an impressionable undergrad, that kind of really sunk in actually and caused me to really question things. And I really had to stop and say, is this what I still really want to do? And even though I've got people that are telling me, don't do that. Don't go there. So that was something that caused a question. I did do an undergraduate senior thesis. I worked with Mr. Guillermo Ferreira. He was fantastic. He was one of the few professors that was, there were several professors in math who were very encouraging of the math majors, was really willing to take on an undergrad who really didn't know anything about doing research and try to start putting things together. If you know anything about what I do right now, it's pretty far from control theory, but I learned a lot about bang controls and advertising from that. Typically, I was the only female or only one of two females in any class that I was taking in the math and science areas, not bio, but in physics and in math at LSU. There were I had no female professors in math or physics at LSU. There was one female math professor on faculty at LSU at the time, right? So this is in the 80s. Things are now very different, but at the time, it was a very, very different environment. And it was, you didn't see the role models, right? And so I found myself looking toward other students. And I've got Leanne's picture here. She was a physics major, one of the few physics majors who was a woman. She was actually pre-med going into psychiatry, and for her senior thesis project, she built an MRI machine. And I thought that was just really cool, preparing herself for psychiatry, right? She was just one of these super motivated, very creative people. And she served as a fantastic role model and inspiration for me going through and taking some of these classes. So what I would say about LSU is it caused me to reflect on whether I really wanted to stay in math and what I wanted to do. So here I was questioning all these things, and then I did 3 DOE summer internships, and they changed my life. And I'm here because of that. The first one was at Oak Ridge the summer before my senior year as undergrad. So this guy, Lenny Gray, in the math division there, he did boundary element methods. This is a type of finite element method in high performance computing. And he would take on undergrads as summer interns. And I think I am the product of exactly what he was trying to do. He would take on students who were not traditionally the ones you would expect to be super great in boundary element methods. And he'd have us come and work, and we probably didn't, I know I probably did nothing useful for him that summer. But I got the experience what a DOE lab environment was like. I got to learn about finite element methods. I learned about high performance computing. I got very excited about it. I was introduced to the IPSC 860 Intel machine. So just kind of ages things. I see Ulrika smiling. She knows. She's heard of this machine. We attended a conference. We went up to Delaware for a conference. And then he also had an environmental math workshop for 2 days at Oak Ridge, and had several professors there from different academic departments. And that's where I eventually met my PhD advisor. So the next internship I did was the summer before graduate school. I went to Pacific Northwest National Laboratory, and I worked with the atmospheric radiation measurement program with Jim Liltigren and Nancy Miller, and started learning about time integration methods, which is something that I ended up still do today. But the idea is they had some data, and they were trying to do some simulations, some time-evolved simulations to help match the data. And they need somebody to try to start coding those forward simulations, and that's what I was working on. And then the summer after my first year of graduate school, I went back to Oak Ridge, and I worked for, I worked for Ed Diaz-Avito and Chuck Romine, doing some linear iterative methods work. By then, Intel had moved on to the Paragon machine. And for those of you who know about some of these machines, the big thing about the Paragon was it moved from a host node format to a node only format. And so there was conversion codes to go from that. But it was further experience working in distributed memory, parallel computing, got introduced to PVM. So is it private virtual machine that was being developed out of Oak Ridge, predecessor to MPI mostly. and just got really excited about continuing on with high performance computing. Okay, the other thing I should mention about this first summer at Oak Ridge, right? So that was a very pivotal time. I learned in that environment that you could do math and science at the same time, right? That applied math existed, and that people, that you could do all that science stuff that I like, but also do math and mix that up. I also got to meet Mary Wheeler, who ended up at this environmental math workshop, who ended up being my thesis advisor. And the guy down the hall at the dorm where they had housed all of us summer students is now my husband. So, if that summer hadn't happened, I don't know what I'd be doing, but it wouldn't be this. So, okay, so in graduate school, I went deeper into numerical methods, high performance computing, and engineering. I went to Rice University, worked with Mary Wheeler and Clint Dawson. So Mary Wheeler got her PhD at Rice University in 1973. And if you want to go to see how many females had gotten math PhDs at Rice University, there was exactly one before that, over 4 decades prior. And so she was the first one to go through that process in modern times, and she had a lot to say about that to her female students. And we learned a lot from her. Yeah. The other thing I would comment is on faculty at Rice at that time. We had an amazing faculty in that department at the time, but we had Mary Wheeler. We also had Richard Tapia, for those of you who know about the Tapia conference, right? We ended up with 50% of the students, the graduate students at Rice University at that time were about 50% were female. So it was a huge change in environment for me, and it was really exciting to see that. I did my dissertation on quite the mouthful, expanded mixed finite element methods for variably saturated subsurface flow. So I worked with groundwater aquifers and looked at the flow of water from the ground as it infiltrates from rivers, lakes, rainfall, and whatnot into our aquifers. Very similar to what we have here in Livermore. So I did a lot of theoretical analysis, a lot of math there, but I also did a lot of programming for the group. Mary's work and her team did a lot of petroleum reservoir simulation as well. I was funded by Chevron for a couple of years. And the mathematics is very similar between oil and water at the time. And so I did a lot of programming, worked on a lot of 3D, linear, nonlinear simulators. Yeah, and all of it was distributed memory computing. I took courses in numerical analysis and functional analysis. I took one computer science class in parallel compilers. So for somebody who had no computer science in undergrad, I did some auditing of algorithms and compilers, and then I took a graduate level parallel compilers, and I wrote a dependence analyzer for Trent. That builds character. And I took some petroleum engineering and flow through porous media classes. I did help teach high performance computing lectures for our scientific computing classes based on work I had done on the Intel Paragon at Oak Ridge, but then also Mary Wheeler's group had a collaboration with Thinking Machines Corporation. We were on CM5 before they were producing them. So I had lots of distributed memory computing. And then I moved to Austin to, when both of my advisors, Mary and Clint, both got recruited to be part of the Texas Institute of Computational Applied Math that Tinsley Oden was putting together. And that became the ISIS Center and then eventually the Oden Institute that we know about today. And so that was quite the experience because there had been this businessman in Dallas, apparently, that had anonymously donated a large amount of money. And Tinsley Oden was setting up this institute and recruiting amazing faculty from around the country to come in. And there was so much energy and excitement. The students were excited to be there. The faculty were excited to be there. We were all co-located. It was just an amazing experience to be part of that right at the beginning. Yeah. And then one thing I do want to note is that Mary did have a number of female students. You often see strong female faculty member in a department will attract several female students. And so she did have several of us that worked with her over the time that I was involved. And for those who don't know Mary Wheeler, she was from Claro, Texas, Texas born and bred, and she had quite the accent. And she would always give every one of her female students what we call grit by grit. It was, gotta have grit. No matter what happens, gotta have grit. And so now when there are trying times or challenges come my way, I've got this in the back of my head, grit. So it was really exciting to me. I remember a friend of mine sent me a note when Angela Duckworth came out with her work in 2016 about grit and how she had done this research and found that perseverance and passion were required. And that's kind of what grit is. People who are successful have this, right? And this friend thought it was really interesting that this was something I'd been talking about, for 2 decades already. Okay, so the other thing to note is that Mary really demonstrated for all of us as a fantastic role model of how to be strong and resilient in the environments that we're in. She was typically the only woman in any environment that she was in. Okay, so for my postdoc, I moved to Livermore. My interview day, I saw no female scientists, not a single one. You can imagine what it's like to stand in front of you all today. This is exciting. Okay. What had happened, my hiring managers were Steve Ashby and Rob Falgout. We went to dinner, and I tried to find a picture of Rob from back when this was. I'm not sure it's quite far enough back, but it's closer than now. At dinner with both of them, I asked them point blank, where are the women? And was told several were moving to NERSC because this was right at the time that NERSC was moving from Livermore to Berkeley Lab. So again, I'm dating myself. And there had been some on staff, but they were moving and they didn't want me to meet with them. They wanted me to only meet with staff that were going to be here if I were to come to Livermore. But they assured me up and down that this was not what they expected to see long-term, that we expected to see more women hired into CASC, which is this new organization that Steve was forming. Yeah. So I was the first external hire into CASC. So CASC, for those not at Livermore, is the Center for Applied Scientific Computing. It is a division of about 120, about 50 or so, 50, as a leader in CASC. Of researchers in math, computer science, and computational science. And at the time we were, I think, 15 when I joined CASC. And it was also an environment where we were building up and, yes, so like TICAM, this is a place that was building up and trying to make a name for itself. And there was a lot of energy and excitement, again, just like I've experienced at TICAM. I joined a very high-functioning team, which was the Parflow team that was being led by Steve Ashby. And it's one of these teams where everybody's working together, sharing ideas, contributing. There was no ego. There was no arrogance. There was just, and there was just a lot of openness. It was a fantastic team to be part of. And it was a really neat experience coming from an academic environment where everybody's sort of independent. And the whole goal is that you could do independent work, right? That's what you do when you try to graduate with a PhD, is you have to demonstrate that. And so this was a totally different environment for me, and I loved it. So not only was I seeing applied math, I was seeing applications, and then I was seeing this team environment. And then for my postdoc, I developed yet another 3D parallel variably saturated flow code. That code is actually still in use today, which is kind of exciting. Steve Ashby did a lot of things really well. But one thing that I really appreciate is he positioned CASC. He sat down and said, how do we put CASC on the map nationally and internationally in computational applied math? And we all had very good travel budgets. We could go to conferences and give talks about what we were working on. And he invited several very prominent computational scientists and applied mathematicians and computer scientists to come and give talks and meet with the staff. So we had lots of conversations about that. With conversations and chances to meet really prominent people. So my postdoc gave me the experience of a team project and fostered excitement in doing applied math at a DOE lab, right? So at this point, I'm getting feeling pretty set where I'm at, which was great. And so on staff at LLNL, I've moved into other areas of applied math and applications. So now I'm going to have one slide that kind of covers a lot of stuff. After my postdoc, I moved into nonlinear solvers and time integration. This was mentored by Peter Brown and Alan Hindmarsh. Peter Brown is one of the reasons I wanted to come to Livermore. He was doing some of the most advanced work in nonlinear solvers at the time, and something I wanted to do and learn from. So when I got through my postdoc, I started working on a project he and Alan were working on, doing nonlinear solvers and time integration. And later, I took up project leadership with that and unified the software into what we know as the SUNDIALS suite, which I'll say more about in a minute. I've participated in the ASCII and then the ASC program as it's changed names. Contributed back in the day to the problem-solving environment effort. I've led 2 L2 milestones for the V&D program. I've worked on the ASCII blue machine, the ASCII red machine, the ASCII white machine, as it's kind of progressed through its thing. It's kind of exciting. There's the ASCII red machine was at Sandia, and we had a deliverable, and we had to do a scalability study on this machine. And so Peter took doing, I think he did the ASCII blue work, and I did the ASCII red work or something like that. And so I got this account on the Sandia systems, and for a long time, if you sent mail to carol@sandia.gov, it went to me. I thought that was cool. Okay, and then I participated in the SciDAC program, the Science Discovery Through Advanced Computing, since its inception. And that program is where I've done the work that I find most interesting, where I can apply numerical methods and software to DOE applications in several areas. And so I've worked in fusion and climate, quantum dynamics, combustion, hydrology, all sorts of different areas. And so we're back to that, being able to do science and physics and math. And so this is exactly what I'd like to do, is to be right at that interface between the science, the math, and the computer science. Okay. So over the years, I've also taken on various leadership positions. I'm going to kind of blitz through some of this, but the project lead for the Nonlinear Solvers and Time Integration project, which became the SUNDIALS project, group leader and CAST for 4.5 years, B Division verification project lead for several years, the computation postdoc program manager, where I advocated for positive postdoc experiences with our postdocs, mentors, and management. And then now I'm serving as point of contact for the DOE Advanced Scientific Computing Research Program, for Livermore, with scientific partnerships and applied math. And there I help facilitate our responses to funding opportunities. And so what I wanted to say about leadership is this takes time and effort away from your own technical work, right? You are now no longer your impact is no longer just what you do, it's what you are enabling others to do. And I strongly encourage folks to consider that changeover when considering any move to a leadership position, right? It's really, really good to take that time to build your own accomplishments in what you've done before moving into facilitating that for others. But it is something that I think is really good, and something that we can all do and help giving back is being able to help facilitate others in their success. The other thing I would say in moving to leadership is that it is always acceptable and important to get training and mentorship in any new position. In any new position where you are doing something different than what you've been doing, there are likely to be considerations in any decision that you make that are different from considerations of what you've been doing up to that point. And so having somebody who can mentor you on what those considerations are, so you don't have to painfully figure them out, sometimes too late, it can be really helpful. And so it is acceptable and important to get training. Just want to make sure, because I'm talking to a bunch of very capable women, you will be tapped for leadership. And I want you to have that confidence to think about the fact that it's good to get, it's not a sign of weakness to be asking for mentorship and training. Okay. The other thing I want to say is I looked at Amanda Randall's talk that she gave here last year. She gave a fabulous talk. For those of you who haven't seen it, hop on YouTube and take a look at it. And she recognized a lot of very strong women in leadership at Livermore. And I wanted to do the same because there are several people who have been fantastic role models for me. But first, I wanted to point out that at the beginning of my career, I got a lot of mentoring because there weren't a lot of women on staff. From Van Hensen and Peter Brown. Both of them in their own ways would spend a lot of time with me. I'd walk into their office and walk out an hour later, but heavily enlightened for me, probably not much benefit to them. But it is, the other thing is it's always good to have those people that you can talk to informally and really don't say, I have no confidence in doing this. Is it okay? Handling family balance. I spoke with Becky Springmeyer when I became pregnant to figure out who, when I talk to my division leader, when I talk to my colleagues, when I talk to everybody, how do I handle all of the doctor's appointments and what are okay things to do, what are not okay things to do. And it's always good to talk to people who've gone through the process. I had seen Becky pregnant in our hallway because she used to be in our building. And so I knew she'd be somebody to talk to. And she was fabulous. Since then, I've spoken to several other women on how to juggle career and family and getting help or not and things like that. And it's really good to talk to folks. What I can say is in general, I've had a very supportive environment. At the time that I was pregnant, I had a group leader. I was a group leader. My division leader was Pete Elkroth. I had missed a one-on-one meeting with him. And I was apologizing all over myself because I hate to miss one-on-one meetings. Somebody's reserved their calendar for you, you show up. And I had missed one and he looked at me and he just smiled and he said, Carol, for now and for the next 18 years, we understand. So now on the other side of that, and it is nice to have had some support and compassion along the way from, those times when the daycare calls and says, your child is spotted. You need to come get her now. Oh, that's true. I spotted. But there have been many, many strong, capable women in LLNL's community directorate over the years who've been an inspiration and a role model community. And one of them, Dawn Crawford, is over there a little bit ago. She sits retired and now runs the Livermore Lab Foundation. They've got an event going on here. But she was our AD for computing for a long time before Bruce. And then we had Dan Kroger, who was department head for a very long, she was a division lead in comp and then department head and then acting AD for a while. And then Lori Dyson, who's been my division leader, now is deputy AD. Peg Folta, who was a division leader, but when I was a group leader, I ended up talking with her a fair bit about various things. Ulrika Yang, who's over here, and I'm probably embarrassing her, but she went through the process of having kids and dealing with work life long before I did. And it has been somebody that, just those informal conversations on the hallway been really helpful in the Ducky. Okay, so let me say a few things about SUNDIALS because I'm going to be running out of time. But I wanted to say something technical today. So SUNDIALS is something that I spend a lot of my time on, and it is a software package for advancing scientific simulations in time. So we do the time integration, whether it be an ordinary differential equation or differential algebraic equation. We can advance it. We've got 6 packages in there, and they all rely on a common set of data structures and solvers underneath them. We're written in C with interfaces to Fortran and designed to be incorporated into existing codes. So they are, we're not meant to be a big framework that you would build a simulation on like PETSI or Trilinos, but meant to be something you pull in when you need it for doing something that you're doing. We were part of the exascale computing project, and so we have a very rich infrastructure to support exascale systems. As mentioned earlier, we've got a lot of downloads and we've got a strong user community in and user guides. I'd be remiss not to mention Dan Reynolds, David Gardner, Cody Bayless, and Stephen Roberts, who are all on our team. We've got a great team right now, and again, a lot of very much like I had with Parflow, a lot of sharing ideas and pitching in to help things are needed and suggesting things and constructive criticism and things like that go on that really make this a pleasure to come to work and deal with. And yeah, okay. So just want to talk a little bit about some of the uses of SUNDIALS. So this one's kind of old, but it was a Livermore one, so I wanted to bring it up. We've been used pretty extensively in the Parodies Dislocation Dynamics package here at Livermore, and we're able to deliver some nice speed ups over the methods that they had when they brought in SUNDIALS. They could speed up one of their nonlinear solvers by 30%. We sped up their time integration very significantly, but it exacerbated a bug in their code, and so they weren't able to use our time integrators so well. But we were able to get some very large, for the time, simulations on the Sequoia machine. We've also been involved with the NICS cosmology code at Lawrence Berkeley Lab. They're moving into updating their integrators for a combustion part of the code, so the chemical mechanisms that they solve. Bringing in SUNDIALS for that, we were able to give a 50% speed up on that, and then that code has now evolved into something that's been running on the Frontier X-scale system. We've been working with the E3SM climate code in developing, when they were developing the new non-hydrostatic dynamical core, so the fluid in the atmosphere, being able to bring in full 3D effects, used one of our integrator packages to try out over 100 different combinations and approaches to doing the time integration. And one of the things that I love about doing numerical software is that it allows people, we can make a package and it can be used in different places in different ways. And it allows people to try lots of different methods without having to totally retool their code to do it. And then we've been using a lot of other places. Power Grid, there's a code here at Livermore, Griddyne, that uses our integrators. Yeah, so lots of different things. Given the time, I'm going to skip the next two slides. But I wanted to mention this one. We've been part of the PLAC combustion suite of codes, and that's a multi-institution code base. Although we work with folks at the National Renewable Energy Lab in Colorado. And it is basically another combustion code. It does solves reactive flow, so flow over within kind of an engine, and at each cell, discrete spatial cell in the solution process, they solve a chemical reaction mechanism, and they use our integrators for doing that. And so this shows, it's a high-res simulation that was done on Summit, which was an Oak Ridge computer. It shows kind of one case of a combustion, and where you see the orange, the bright orange and red is where the diesel fuel is about to ignite. And so they've got some great simulations with that. So PLAC running this was one of the first codes that was able to run on Frontier scale system a year ago, January. And used our code, our integrators within that. And so they were able to solve a 2.4 trillion unknown problem with SUNDIALS under the hood Frontier, which was really, really exciting to us. And as somebody who worked on the Oak Ridge IPSC 860, to be able to have code running on Frontier was pretty cool. Okay, running out of time. Let me just say, one of the things that I try to do is I've benefited tremendously from so much support from the community, and I try to give back through a lot of professional society service. I've done a lot of things. This was mentioned in the intro. I have the slide where I talk about some of the things I've done. I don't want to spend a lot of time here, but I really think it's important, once you become senior enough, to be able to use your voice to encourage other women and encourage change toward equality. And I'm approaching this a little carefully, because if you are too early in your career and don't have enough clout and you advocate for change, you can get some people unhappy with you. It's once you've got a little political capital to expend that to try to encourage change, I highly recommend to do it. And when we are in a position where we've been, if you find yourself on a committee, you are the one female on the committee or the one lab person on the committee or the one whatever on the committee, then it's up to you to use your voice to advocate for the population that you are representing, whether or not it's explicitly stated that that's who you're representing. So I'm happy to talk with folks about that, but just wanted to introduce that. Okay, so some advice. Find the flame that drives you and seek environments where your sparks can flourish. I know that sounds so quaint, but I think it's really true. Somebody told me this advice when I was really, really early in my career, and it's true. You want to find environments where you know what excites you, but then find environments where that can really find at home. It's not going to be snuffed out. People feeling empty. Look for places where you feel excitement and energy, right? For me to join CASC when it was young, to join TICAM when it was young, even my high school, I was the third graduating class from that school. I've had 3 instances now where I've been in a super excited new environment, and that's really energizing. There's some environments that have been around a long time. I mean, well, lab's been around a long time, but there's a lot of energy right now, lab, right? There's a lot of new folks here. It's an exciting time, I think, to be at Livermore. And look for that and really try to capitalize on it. Don't be scared to get out of your comfort zone and try new things, right? I moved out of my family when I was 16, went to a totally new place where I didn't know too many people, and it was the best thing I could have possibly done. I was in the DOE lab, didn't know anybody. Had my suitcase and, got a ride to the dorm and, but it's exciting. You can really find, getting out of your comfort zone, you can find new dimensions and new strengths that you didn't know you. Okay. Having highly capable women who are visible is often an indication of an environment where women's contributions will be appreciated. And so with CASC was the exception for me, but other environments where you see a strong woman visible are usually an indication that you're going to have a home there. So something to think about. And then giving back through mentoring, professional service, or other avenues is a great way to pay it forward. Okay, so my last slide, I promise, my favorite recommendations. Somebody handed me this article when I was very early in my career. I really like it. It's like 8 or 9 pages, came out of the IEEE. And the basic point is to, when you are in a job, look for what needs to be done, not just what you're being told to do. And I really like that thesis in this pretty short article. You can still find it on the web. If you're a postdoc of mine, you've been handed a copy of the last lecture by Randy Pausch. He's got some interesting things to say, but one of the things that I really, really like that he gets to in this book is live your life intentionally. Think about what you want and make sure that when you are doing things you want to be doing. Also, if you're a postdoc of mine, or you were in the CASC postdoc program or the Comp postdoc program for several years there, you were handed a copy of The PhD is Not Enough. That's my fault. And again, if you're in a research career, then this book really has a lot of good considerations as you're putting together your career at the early times. I'd really recommend that. And Will Duckworth, you got to have for it. And then some of us have been reading How Women Rise by Sally Helgeson and Marshall Goldsmith. This is a more recent book, and I blame Ulrika for suggesting this for all of us to read. But this has been actually a really interesting book about some of the habits and tendencies that we as women do that can kind of undermine us, but then also things that we can do that can really help us advance. And it takes a very a viewpoint from typical habits of women in workplaces. Okay, and I think that is it.
When you've taken on projects for which you didn't have directly related prior experience, for example, your Oak Ridge internship, how, as an applicant, did you show your capability to do that project? More generally, do you have advice for people pivoting careers or research areas and thus are looking to showcase transferable skills?
Oh, that's a lot. I have no idea why Lenny Green chose me to go to Oak Ridge that summer. Right. I think it's really important if you have an option for personal statement to express your passion and energy for what you want to do. So I think, you know, if the application form has that option or cover letter, if you're applying for a job, be able to express, you know, your interest and excitement in what you're applying for. I think that's really important. Absolutely transferable skills are what you want to highlight if you have them. If you don't, then it's really good to do what you can to develop them ahead of applying. So, for instance, you know, we looked at a job applicant once who had no coursework where they had to learn LaTeX. So LaTeX is a typesetting package for math. And we used it for all of our documentation for SUNDIALS. And when asking on the interview, you know, we said, do you have any LaTeX experience? And they said, oh, I'm a LaTeX enthusiast. Here's my GitHub. You know, take a look at this and this and this. And so they hadn't had any time in class where they'd had to learn it, but they'd learned things on their own. Did they learn it the best way? Maybe not. But the fact that they had done it, that tells me they've got interest. And that's something I can work with in Guide, right? And so that's a huge thing. So I think if you are trying to move to a different area, trying to do some self-learning and do it in a way where you can have some artifacts that you can leave for an interviewer or an evaluator to see, I think is very helpful.
Can you talk a little bit about, what's the term I want to use, like swinging up? A lot of women that I've talked to are afraid to apply or don't think they're qualified or don't think they're worthy of applying to a job that's just out of their, you know, expertise level. So do you have any like kind of sayings that you have, you know, those kind of gotten yourself pumped for, you know, or do you have any kind of tricks or anecdotes about like, you know, why don't we deserve this next step, this job? How can I feel qualified?
So two strategies that I've used. It really helps to have a cheerleader in your life. So somebody that you can go to and say, I'm thinking about applying for this. I don't know if I'd be qualified. And then just dump all of your misgivings and uncertainties. And that person just looks at you and says, you can do it. You know, having that cheerleader is extremely valuable for me. Right? And I know that's not necessarily transferable, but I think we all need to have a cheerleader somewhere. And if you don't, go find one. And maybe it's another woman who's you know, in an area that you're in or nearby, and you could be each other's cheerleader, right? It's really, really helpful to develop. The other thing is the realization. A friend of mine once said, this was back in graduate school, and he commented that a man to feel confident in front of a group of people needs to have one person in the audience that they know is confident in what they're saying, right? But a woman generally wants to have everyone in the room confident in what they're saying. And I think that's very right. And it is something that holds women back tremendously. And I really think that just really internalize that realization and try to resist your urge for having a misgiving when you feel it, with this understanding that you're having this misgiving because you don't feel that everyone who's going to evaluate you in this new position up isn't going to be on your side. Well, okay, but if you've got one, that helps, right? So try to think about it that way, right? And the other thing, I guess a third thing is if you're trying to move to a position that you haven't been in, go talk to somebody who's been doing it. Find out what's involved, because your male colleagues are doing that. Absolutely. they're going to them and saying, what did you do when you interviewed? What did you do for this? What did you, what are the big challenges? Where do you think we should go? Women tend not to do that enough.
One thing was a comment, and if you wanted to comment on it, right? And then the other is a question. So Stephen Ashby's now the director of PNNL, is that right?
Yes.
So I just thought that's cool. You obviously got to see his evolution too, and just thought interesting. I know that you interned there at least one time. But then also with your mathematics background, and I don't have a strong mathematics background, but obviously there's a lot of application and need for better foundations in mathematics. And so I was kind of curious what you might recommend for early career people that are trying to, want to grow their skill set and be meaningful to whatever project, but might need to learn some of those kind of steps. Is that something that you just kind of have to figure it out and like make the time on your own? Or is it usually like kind of a part of the program where you can get some of that from like a project that you might become trying to become a part of or something?
So I guess you're asking if you are wanting to do a position, a job or position, and you don't have all of the skill set, what do you do to try to get there?
Yeah, I mean, it's kind of like to get in the door. It's good to have the skills already, and it's pretty much usually required. But if you're maybe somewhere trying to work on how to kind of keep moving forward and up, I guess what would you maybe perhaps recommend, having mentored other people and been a leader now?
So a few things, right? So if you are, for folks at Livermore, we do have an education program. So I don't know if you're Livermore, but
Intern.
okay. For staff, there is a tuition assistance program that does help, right? So we had somebody in our team who wanted to learn more applied math and was able to do a master's in applied math through the University of Washington virtually, right? Had fantastic faculty for that. Actually ended up doing that during COVID and had amazing faculty because everything was online. And so he was able to take anything. But in general, it was that sort of thing can help with taking classes at universities and whatnot. So if you're in a work environment where that's allowed or provided, then great. If you are not, there are many universities have like extension programs where, like if you want to learn machine learning right now, you can go to Stanford, Berkeley, or, all of these places have adult education programs and classes and communities. There's also a ton of different technical topic classes online now that is an artifact of COVID, and a lot of that's free. You've got to search around for it. And so there's a lot of stuff that you can do on your own, but not everybody's a great learner on their own, and it's nice to have somebody to ask questions. And that's where reaching out and talking to people who are doing the position you want to go into, say, hey, I'm going to do this class online. Can I use you as somebody I can talk to with questions, right? Things like that, and try to set up a support network around yourself to as you learn. But there's going to take a lot of self-motivation there. And if you're still in school, then by all means, go take a class somewhere in a different area. If you want to go into a different area, go take a class in there. Hopefully you find you still like it. Some people do. They take it and go, no, I don't ever want to do that again. Okay. Great to know now.
Big dick.